Hello everybody, so today we're going to look at calculating the number of electrons in 2.3 grams of sodium metal. Now, if we're reading this, normally it's a subatomic particle equation there in terms of finding out your number of electrons. But this is slightly different, okay? Let's have a look why that is the case. We do our Na here. Now, if you look at your periodic tables, okay, and you go to sodium there, you'll see Na has 11 there, and down here it'll have 23. Okay, so what do those numbers represent? Well, we should know that at this stage, really. Okay, is the 11 is your atomic number, which basically means the number of protons. And 23 is your mass number, which is number of protons, plus number of neutrons. And we know in a neutral atom, okay, the number of protons, okay, so neutral atoms, I'll write it down. The number of protons equals the number of electrons. The number of electrons. If it was an ion, this would be different, as we've seen before. So they're equivalent to one another, so that's grand. Okay, so if we have 11 protons, we'll have 11 electrons. Okay, so we'd be thinking there, well, is that it? Are we done? So really, well, we're not, because if before when we've been doing these subatomic equations, we've been dealing with one atom. But in this case here, we're asked to find out how many electrons are present in 2.3 grams of sodium. Well, we can assume that there's going to be more than one atom. Okay, if it's 2.3 grams, there must be, come on. So we have to use another formula. Okay, so we have to basically find out how many atoms are present in 2.3 grams. So I'm going to write out my formula that we need to use. So that is our number of atoms equals the number of moles times Avogadro's number. And just to go back to the last one there, just so I'm very clear about this, that this here, the number of electrons here, okay, is per atom. Okay, there's 11 electrons per atom, but how many atoms are we dealing with? Okay, so if we fill in our formula there, and we'll quickly see that we don't know what the number of moles is, and we do know what Avogadro's number is. That's standard enough, 6 times 10 to the power 23. Okay, so how do we figure out what the number of moles is? Well, we use our normal formula for that. So you just go over here and I'm going to plug that in now. Number of moles equals mass over the MR. Okay, so that number of moles is equal to, if we're finding the mass, we're told it's 2.3 grams, which we're told up above. Okay, and the MR, all you do is you go over here, get your molecular mass, and your MR is 23. So we're dealing with 0.1 moles. So I'm going to plug that up here. So it now becomes 0.1. I put everything into brackets, so it just makes things easier, multiplication for scientific notation. And if I multiply the two of those together, okay, we're going to get 6 times 10 to the power 22 atoms. Okay, so that's great. We have our number of atoms here. Okay, and we know that every single atom contains 11 electrons. So all I'm going to do now is I'm just going to get that. So 6 times 10 to the power 22. I'm going to multiply that by 11. And that will equal to our total number of electrons. And again, put everything into brackets, and when you do that, it becomes 6.6 times 10 to the power of 23 electrons. Okay, so let's just recap that. You're asked for how many electrons are present in 2.3 grams of sodium. Okay, so we can do out our normal formula here, and we know that number of protons equals the number of electrons. If it's neutral, we can assume that it is, because you would be told otherwise. And in this case here, that means we have 11 electrons. That's 11 electrons per atom. How many atoms do we have present in our sodium metal? We use our key formula here. Is number of atoms equals the number of moles times Avogadro's number. We know Avogadro's number, 6 times 10 to the power 23. We have to figure out what the number of moles is. But you are told the mass. Okay, so therefore we can use our traditional formula for finding the moles, Number of moles is mass over MR. 2.3 grams divided by the 23 molecular mass, it gives you 0.1 moles. I pop it up here, we get a number of atoms. I multiply my number of atoms there by 11 because each atom contains 11 electrons, and we get 6.6 times 10 to the power 23 electrons. And that's it, guys. There's a bit involved in it, I know, but practice and more practice and you'll get it. Okay, all the best.